Good morning all my dear students. This it is our second lecture of engineering materials. In this lecture we will study about the conducting polymer and electroluminescent polymer. Polymers or plastic as they are also called are known to have good insulating properties. We will see that conducting and insulating property, but before that what is difference in between polymer and plastic? Plastic, it is nothing but the polymer, but with that polymer some additives are added like extenders, fillers, dye, wax, oil, that that is also added, and then the end product, it is called as plastic. We can add some specific property in that by adding the additives. That is nothing but the plastic. But polymer and plastic both are having good insulating properties, so we can use that to coat metal wires to prevent electric shocks. Polymers are one of the most used materials in the modern world. Though we are saying that, or though we are always talking about the pollution because of the plastic, then also we are using it. Why? Because the uniqueness of that polymer, it is having long shelf life, no degradation is there, and also by changing a small thing in its structure, we can get something specific property. We can change the property of that material by small change in its structure. So this it is uniqueness of polymer. Their uses and application range from containers to clothing. If we want any good mechanical strength, there also we can use that plastic. If we want flexibility in material, there also we can use that polymer or plastic. So this it is having number of uses, number of applications are there, and one it is having good insulating property, so we can use it as an insulator. But its insulation property, it is changed by a group of three scientists. Group of these three scientists, they discover that a polymer, that is polyacetylene, can be made conductive, and its conductivity we can compare it like a metal. In 2000, the Nobel Prize in Chemistry was awarded for this discovery of to this group of three scientists. This is the structure of trans-polyacetylene. This is the first member of polymer that is conducting, so this it is important. Now the structure of that polymer, it should allow the conductivity, but for that some conditions are there. What are the conditions? Conditions are they are conducting on virtue of their structure. Their structure, it should allow the conductivity. What is conductivity? That is passage of electron, transfer of electron from one end to another end throughout the polymer chain. That is nothing but the conductivity. For that, two conditions are there. One, it is high planarity, it should be there, and it should possess conjugation. So when we will apply that external electric field, pi electrons, it will get excited, and then they will freely move throughout the polymer chain because of the conjugation. This it is the first, that is trans-polyacetylene conducting polymer. Then other than that, number of other conducting polymers are also there, like polyaniline, polyparaphenylene. Now in polyparaphenylene, the benzene ring conjugation is there, so no breakage is there in that conductivity, so it will allow the passage of electrons from one end to another. If you will see that structure of polyaniline and polyparaphenylene, what is difference is there? Two benzene rings are joined by NH group. Now this nitrogen, it is having lone pair of electron, so that lone pair of electron, it will also help the transfer of electron from one end to another. These types of polymers are called as intrinsically conducting polymer. Means the structure itself, it will allow the passage of electron from one end to another throughout the polymer chain. This it is also first type of the conducting polymer. Three types of conducting polymers are there. So first one, it is intrinsically conducting polymer. Means the polymer, its structure itself, it will allow the passage of electrons from one end to another. So that is ICP, intrinsically conducting polymer. Examples are trans polyacetylene, polyaniline, polyparaphenylene. These are also example of ICP. Here heteroatomic conducting polymers, that is polypyrrole, polythiophene. So in polypyrrole and thiophene, nitrogen and sulfur with lone pair of electrons, so there will not be breakage in its conductivity. These two will help, its lone pair of electron will help the conductivity, passage of electron from one end to another. One more example is there, and that is polyaniline, that already we saw in previous slide. Now these intrinsically conducting polymer, whether it is normal or heteroatomic, we can use that polymers in light emitting diodes, PLED, or solar cells and photodiodes, where we need a small amount of electricity. There we can use these ICP, that is first type of conducting polymer. Intrinsically conducting polymers are poor conductors, but if we want to improve its conductivity, we can improve it by creating positive or negative charge. So this, it will help in transfer of electron from one end to another, and this, it is nothing but the doping. This, it is called as doping. Two types of dopings are there. First is p doping. Doping of ICP with Lewis acid, that is done. Because of that Lewis acid, there will be oxidation. Oxidation, it is nothing but the loss of electron. Because of that, there will be creation of positive charge, and this, it will created on that polymer chain. This positive charge, it will help in transfer of electron from one end to another throughout the polymer chain. Which Lewis acids we can use? That is iodine, bromine, FeCl3, PF6. So for p doping, these acids we can use it. This, it is the reaction C2H2, that is polyacetylene, and FeCl3 if we are using, then there will be creation of positive charge. Second type of doping, it is N doping. There is creation of negative charge. Here the ICP, it is treated with Lewis base. Reduction, it is done, that is gain of electron. Because of that, there will be formation of negative charge. This, it is created on that chain. This, it will help in transfer of electron. Lewis bases which we can use, that is lithium, sodium metal, naphthylamines, that we can use. In that same, the example it is given, that is in polyacetylene. If we are treating it with sodium, then there will be creation of negative charge. Then the third type, so this, it is the second type, that is doped conducting polymer. So here we will get good conductivity, good improvement in its conductivity of that polymer. But if we want to improve its conductivity more, then the third type of polymers are there, and that is ECP, that is nothing but the extrinsically conducting polymer. Here also we are compounding some another material, conducting material, in that polymer, but here in its structure we are not making any difference. So this, it is called as extrinsically conducting polymer. Conducting materials like metallic fibers, metal oxides, which conduct that electricity, so that is that are added in that polymer while molding, or blending of conducting polymer with conventional polymer, physically or chemically it is done. So in that ICP or doped conducting polymer, if we are adding metallic fibers, metal oxides, so that is also done. Or the second type, it is with conducting polymer, some conventional polymers are added with which are having conductivity. So this, it is the third type, that is extrinsically conducting polymer, ECP. So three types are there: ICP, then doped conducting polymer, and extrinsically conducting polymer. One example we will see of conducting polymer, that is polyacetylene. This trans polyacetylene, it is accidentally discovered in lab of Professor H. Shirakawa. The student had polymerized acetylene 1000 times the amount of catalyst, that is Ziegler-Natta catalyst they were previously using. So because of that accident, what happened? Actually they were getting some powder form of that polyacetylene, but because of the increase in that catalyst, amount of catalyst 1000 times, so they got that polyacetylene in polycrystalline, flexible polycrystalline film. And after that, later Shirakawa, he collaborated this work with other two scientists, and they did oxidation on that polyacetylene, which increases the conductivity of that polyacetylene. So without oxidation or without doping, conductivity of polyacetylene, it is 4.4 into 10 raised to minus 5 Siemens per centimeter. But because of doping, it can be oxidation or reduction, but that conductivity, it increased too much, and that is 400 Siemens per centimeter. So this, because of this research, they got Nobel Prize. What is the mechanism of conductivity after doping? This, it is the undisturbed conjugation, alternate single and double bond is there, nothing disturbance is there, but whenever we will apply that electric field, then because of that conjugation, because of that alternate single and double bond transfer of electron, it will be, but its intensity, it can be increased because of the doping. So this, it is the first oxidation it is done, and there we will get radical and cation. So one radical and one cation because of first oxidation. So this, it is called as positive polyron. But when the second oxidation, it will be there, then two radicals we will get, two cations we will get. But because of that, now the next thing, it is combination of that radicals it will be, and then there will be formation of a new bond, and here positive soliton we will get. So likewise, this positive soliton, number of positive solitons will increase, and then the transfer of electron, transfer of conductivity, it will be from one end to another throughout the polymer chain with good intensity, with improvement of conductivity. These are the applications of doped polyacetylene. We can use that in electric wires. So if doping it is not done, then we can use it in LED. But if doping it is done, its conductivity, we can compare it with electric wires of metal. So we can replace that metal electric wire by polyacetylene, doped polyacetylene. We can use that in transistors, photodiodes, light emitting diodes, telecommunication device, in solar cells, drug delivery system for human body, molecular wires, switches, there also we can use it. But with that applications, there are some limitations also. What are the limitations? Few large scale applications, but high cost is there because of the processability and workability. This, it is having some high cost. Problems are there because of the insolubility, infusibility, and brittleness character is there in that polyacetylene. So this, it is problems are there in processing, and long term instability is there. So because of that, the we can't use that polyacetylene everywhere. Second type of polymer that we have to see, that is electroluminescent polymer. Before that, what is electroluminescence? Electroluminescence is a phenomenon in which material emits light in response to the passage of an electric current or strong electric field. We can see this phenomenon in some semiconductors of low molecular weight inorganic matter, or we can see to lesser extent that in organic material also. So this process of luminescence, it is nothing but the combination of electron from one electrode, and this electron will be captured by the hole of another electrode. So because of that combination of electron and hole, there will be emission of light. Now if this phenomenon it is in polymer, then that type of polymer, it is called as electroluminescent polymer. So electroluminescent polymers emit light in response to the passage of an electric current or presence of strong electric field. first electroluminescent polymer that is reported in polyphenylene vinylene. In short, it is PPV. So this, it is PPV, it is nothing but the semiconductor polymer, and this semiconductor polymer, it is sandwiched in between metallic electrodes, and there is the combination of electron and hole, and because of that combination there is the emission of light. So that is nothing but the first PPV electroluminescent polymer. Major application of that PPV, it is in light emitting diodes. Polymers or plastic, as they are also called, so are known to have good insulating properties. We will see that conducting and insulating property, but before that, what is difference in between polymer and plastic? Plastic, it is nothing but the polymer, but with that polymer some additives are added, like extenders, fillers, dye, wax, oil, that is also added, and then the end product, it is called as plastic. We can add some specific property in that by adding the additives. That is nothing but the plastic. But polymer and plastic both are having good insulating properties, so we can use that to coat metal wires to prevent electric shocks. Polymers are one of the most used materials in the modern world, though. So this one, it is the construction of electroluminescent polymer. This, it is one diagram it is shown, that is of typical single layer polymer LED. Here what is done, this semiconducting polymer, this it is taken, and this it is sandwiched in between two electrodes, cathode and anode. Cathode, aluminium, calcium, magnesium, any metal that we can use it. Then anode, typical anode which is used, that is indium tin oxide. Indium tin oxide, it is transparent material, and then in between these two electrodes, the semiconducting material, semiconducting polymer, this it is sandwiched, and this, it is that layer, it is deposited on plastic or glass substrate. Then whenever we will apply that external electric field through that indium tin oxide, positive charge, that is hole, this it is injected, and from the cathode electrons are injected. So through that semiconducting polymer combination, it will be there, combination of electron and hole, it will be there, and because of the combination, in response to that, there will be emission of light. And if it is PPV, then because of small band gap, we will get the yellow green fluorescence, yellow green fluorescent light that we can get. What are the properties of PPV? PPV is a diamagnetic material. Its conductivity, it is low, and that is 10 to 13 Siemens per centimeter. Its conductivity, if we want to increase, then it can be increased by doping. Alkoxy substituted PPV shows ease of oxidation. This, it is water insoluble, and this, it gives bright yellow green fluorescence on application of electric field. Ease of processing, high tensile strength, elastic nature renders PPV to be used under harsh conditions. So this, it is the PPV, polyphenylene vinylene. These are the applications. Due to stability, processability, and electric optical properties, this it is used in LED. It gives this bright yellow green fluorescence. So different color light if we will need, then derivatives of PPV that can be used. Depends on that derivative, we can get the different lights. PPV also used as electron donating material in organic solar cells. So that is also one good application of this electroluminescent polymer. Thank you.